Hello, my name is Timothy Mulcahy, and I'm going to talk about a topic I think many people will find useful and something that may affect lots of people, as it's estimated that billions and billions of people around the planet consume coffee on a daily basis. And has been noted many times before, coffee houses were the center of innovation during the period of enlightenment. And many of our technological advances today we may be able to trace back to some thoughts that were made in a coffee house a long time ago. And so I think that coffee is not just an important part of my day, but many people's day, and something that many people enjoy, and something that may help us in our thinking and creativity processes, and certainly helps us give us a kick of energy to get more things done in a day than we normally would. And so let me discuss the problem that I've been having with my machine and a solution to improve upon it. But before I do, let me get a sip of the coffee I have right here. Mm. Okay, so as I was saying before, coffee is a critical part of many people's days. Um, And so, a particular problem that I was having is that my machine, my coffee machine, espresso machine, and many machines I've had before and many machines that I've seen don't have a way of alerting people, telling people what the water level is in their tanks and their reservoir tanks that make the coffee themselves. Um, and this can be a big problem, especially for my machine, as it goes through a long priming cycle. Once you refill the tank itself, it cleans all of its lines and does some other things every time the tank is refilled, which it takes several minutes for this to happen. If you're in a rush and out the door, in a rush to get out the door rather, to work or to somewhere, and you want to grab a cup of coffee, if that tank runs out, midway, it can cause a big problem. And potentially on older models of coffee machines, there may be other problems as well. Machines may not know that they're out of water, and they may overheat. They may do damage to the machine. This could be a potential fire issue. So there's many reasons why this problem could affect people in many different ways, and there's definitely a problem with these embedded devices that are coffee machines, espresso machines. Could be a potentially serious problem if it were to cause a fire, besides just the inconvenience of it. And so came up with a solution. My solution was to come up with an embedded device that would be able to tell me, what my coffee level water level was in my tank for my coffee maker. It would easily be able to present this, and then I could have this information readily available, whether I was near the coffee machine or not. I could take a look and know, and it was convenient, and then I could get some warnings if it was getting too low. So we came up with an Arduino board as the basis, sort of the centerpiece of this system, and then connected to a conductive water level sensor that would sit in the tank. There'd be some custom software that would read the voltage coming off that conductive water level sensor, converted that analog signal into a percentage that would then display on an LCD screen. Would also send that percentage to a web portal that I would create, and if things got too low, the LCD screen would flash, causing people to take notice if they were in the room. And you could also see what the water level was in the web portal itself at all times, and you could adjust how often it would send what the level was to the portal. We could take a look at the basic hardware here. We had an Arduino board, water level conductive sensor there, some wires for connections, an LCD screen. Bottom left, we can see some of the software here. There's the Arduino IDE with some of the software I wrote that wouldn't just send, would connect to the web portal, connect to Wi-Fi, connect to the HTTP client, send the information, communicate back and forth. We do the calculations for what the percentage of water in the tank was, display that on the LCD screen itself. And on the bottom right, we can see some PHP code that just acted as the basic web server, consuming this information and then displaying it in an HTML page. Some problems along the way. One sensor wouldn't be long enough in order to fit in my tank. So I needed to use 2 of them, so we had to solder to the voltage pins, wire connections there together. So I soldered those together, put them into one, which increased the voltage potentially running through that line after the 2 were connected. But it also caused a problem because I needed to waterproof the one sensor that was going to be submerged. So that sensor also, besides reading the voltage line, it has a ground and a power line that come into it. That all need to be waterproofed, and just use some rubber coating from a local hardware store there to coat that and make that all those connections waterproofed, so that they could be submerged and still not affect their readings or their electricity supply coming into them. Here you can see the staggering of the 2 sensors there so that we could get quality readings inside the tank themselves. And since these 2 tanks voltage lines were then soldered together into one line coming back to the Arduino board, we had to adjust the software reading itself because we could potentially have twice the voltage coming through that line back into the Arduino board. So we had to make some changes there in the software to have an accurate reading. And then we needed a way to tell what those percentages should be. So we had to sort of calibrate and we did this by taking physical measurements. So the tank is full 100%, and then when the tank was 0, we were able to take those and then just physically measuring what would be 75%, 50%, 25%, 10%, measured those out, marked them off, and then adjusted our logarithm in our code itself so that when we could see those physical measurements where they were supposed to be, that our percentage on our LCD display, or what our code was calculating, was the same and or similar. And we were able to get pretty close here, so able to be within about 5% most of the time. At the extremes, we is where some of the issues were when the tank was very close to empty or very, very full, read slightly off. But for the most part, I was happy with the results that I was able to get in getting these measurements fairly accurate. And then sort of the test for the web server, able to send the information to it successfully, no problems, updating it whenever, whatever interval I like. And it was accurately able to log this information. And so this experiment, it was successful, I think, for the most part. We're able to display these water levels, accurately, conveniently, and able to get on-demand access to the data. As I showed, there were some difficulties with, soldering, multiple sensors together and making some of them waterproof. But we were able to sort of overcome these and get it to work. If more time was allowed, I would probably build some housing to put all this in, which I think, can make it, look more, aesthetic and maybe improve functionality a little bit. I would also, potentially read the pH of the water, any particulate matter in the water, maybe the temperature of the water. Use a better LCD screen, display all that information, and report all that information to the web portal itself. And then the UI on the web portal could definitely be improved, and maybe ease of access for that web portal. Maybe create a native app for iPhone or Android to be able to check all that information. We can see a quick display here. Here is the machine operating. And this is just going over the problem again. So we can see the machine itself here with the LCD screen displayed. And you can watch this whole video. I'll forward a little bit here. We'll see it's at 76%, so it's close to full. Take a look at the web portal. So we're going to see at the bottom there, the web portal is at 76%. And the date and time are right there, timestamp. So we'll make a cup of coffee here. So you can see the percentage that's there, and it gives you a little readout. It says close to full. So it grinds the beans, compresses them, and then it pulls the water in from the reservoir here. And as it pulls the water in from the reservoir, we should see a change in the percentage of the amount of water that's in the reservoir. So it takes just 1 second here for it to begin. Okay, so it's pulling water in, continue making the coffee. And then we have there's a 10-second delay on update, and we see the drops there to 72%. See another drop to 70%. We should see another drop here. There we go. Continues to drop as water's pulled out to make the coffee. And then update in the portal itself, we can see 66%. It's dropped again to 63. So it's all successful. So I'll pause that. So thank you very much. I hope you enjoyed the presentation and the project itself. Take care. Bye-bye.